So we're now going to turn our attention to the Java function functional interface. And we'll explain what this functional interface does, and then show how it can be used in conjunction with Java Lambda expressions and method references. And we'll also take a look at an example to show how you can apply Java function in practice. This particular example showcases the Java Collections Framework's ConcurrentHashMap class, which is a very useful class that we'll come back to many times throughout this course. We'll also show how to compose Java function objects together, much like we showed earlier how to compose predicates together. So let's start by first giving an overview of the function functional interface. A function applies a computation on one parameter and returns a result. And these parameters types are specified as generics. So you can see that we have type T, which is the type we pass as the parameter, and we have type R, which is the type that's returned as the result of applying the function. There's an abstract method called apply, and that's passed a parameter of type T and is going to return a value of type R. So let's talk about how you can apply the function functional interface. So this particular example, which is found in the EX9 project in my FP folder in the Modern Java GitHub repository, uses the Java function functional interface in conjunction with ConcurrentHashMap to compute, cache, and retrieve large prime numbers. This is the instance called prime cache, which is a concurrent hash map. It's going to cache the results of these long-running prime number computations. And this particular technique we're going to look at is often referred to as memoization, which is just a fancy way of saying caching. So if you want to learn more about memoization, please take a look at the link at the bottom of the slide. There's also a nice discussion of memoization in the book Java Concurrency in Practice by Brian Getz and his colleagues. So the way this works is we're going to leverage a particularly useful method on ConcurrentHashMap called computeIfAbsent. And what this method does is it will atomically check to see if a key is already associated with a value. If it is, it's just going to return that value. If it's not associated with a value yet, it will atomically compute the value using the given mapping function and then store it in the map and then return it. And this is often referred to in the literature as atomic check then act semantics. And the key thing here is this has to be done atomically, very important. Now, the function that's used in order to compute the value, if there isn't one associated with that key yet, can either be provided as a lambda expression, as we're showing here, where we're going to pass in the result of calling the isPrime method on the key. And you can see isPrime in this case will return 0 if a number is prime, or its smallest factor if it's not prime. So that's one way to do things. Or we can pass it as a method reference. So here is a bit more concise way of doing things. We use the prime utils : dot isPrime syntax to indicate that we want to apply the isPrime method if there's not a value associated with the key yet. So let's take a look and see how ConcurrentHashMap uses the function interface internally. So here's the computeIfAbsent method, which is one of the methods defined on ConcurrentHashMap. And you can read more about this method at the link at the bottom of the slide. And as you'll see, it's passed in a mapping function. And it uses that mapping function to take a key and then compute the corresponding value if there's not already a value associated with that key. And I'm just showing you a little snippet of the implementation code. You're welcome to look at the code. It's all open source, naturally, along with the rest of the Java class library. And this particular code is also well protected by clever synchronizers, so it works properly in a multi-threaded context. The particular syntax here is a little interesting, so I want to mention it briefly, even though it's a bit outside the scope of the discussion. This function is going to take two generic parameters. The first one is going to be the one that defines a lower bounded wildcard, which restricts the type we're defining here to be either a specific type or a super type of that type. And that's what's called lower bounded wildcard. And then over here, we see extends, which defines an upper bounded wildcard that restricts the unknown type to be either a specific type or a subtype of that type. So there's two different ways of defining these things. And you can read more about this if you're curious by taking a look at the link at the bottom of the slide, which talks about type wildcards in generic Java. Moving back to our example, here we can see that there's actually a binding of the prime utils is prime method or method reference to the mapping function that's passed as a parameter. That's what we're going to pass in, or we saw how we passed it in before. And this is how it works when the mapping function.apply method is called. It's as if what it was really doing was calling the isPrime method with the key and then storing the result into the value, which is then used to update the contents of the map with the appropriate synchronizers held in a very clever way. So that's a quick overview of how ConcurrentHashMap uses the mapping mechanisms of a function. Let's now talk about how you can compose Java function objects together. So this particular example is also found here in my GitHub repository, in the EX10 project in the FP folder, in the modern Java repository. And this is going to show how you can compose function objects together. And this is called the HTML tag maker. And you can see here we define a couple of methods, one called add less than. You give it a string and you essentially prepend the less than string to the string that's passed as a parameter. We also have another method called add greater than, where we append the greater than symbol at the end of the string. And then we're going to go ahead and define a couple of Java function objects. The first one is called less than, and you can see it maps string to string. And we give it the HTML tag maker : add less than method as the method reference. And then below that, we have another function called tagger. And tagger is going to take the less than function and then connect it or compose it with the add greater than. And when we do that, when we compose these two things together with the and then method, the and then method is used to compose two function objects together. We can then call the apply method on the tagger. And as you can see here, that will print out the appropriately tagged strings. Just a fun little example, nothing too profound, but just demonstrating how you can compose function objects together in a realistic way. And you're welcome to play around with that code as you see fit to modify it in ways that you may want. So that's the end of the overview of the Java function functional interface.